Just seems really relaxing. But yeah.
Awesome. I see Megan Arsena joined. Would you like to participate in the icebreaker?
Yeah, sorry, pressing wrong buttons. Anyways, I'm Megan. I'm a third-year mechanical engineering major. I don't know, like, I kind of want to go everywhere. Like, and I love Greece and Rome because I have an obsession with mythology. I want to go to New Zealand because they have, like, bungee jumping. My grandma's from England, so I want to go there. So, yeah. That's kind of anywhere but America right now. I mean, that'd be great.
Yeah. Nor, would you like to go next?
Yeah, hi everybody. My name is Noor and I'm a fourth-year civil engineering student. Sorry for the music in the background. I just got done with the gym and I'm walking out. But I would love to travel to Scotland and also throughout the Middle East. I've been to a few countries there, but I definitely want to go to like the UAE and Oman and just places there. I think it'll be cool.
Awesome. That sounds exciting. Natalie, would you like to go next?
Yeah, I'm a freshman civil engineering major. And if I could travel anywhere, I would probably go to New Zealand. Seems like a really nice country.
Mm-hmm. Absolutely. Nicholas, would you like to go next?
Yeah, my name is Nick. I'm a first year in computer engineering, and if I could go anywhere in the world, I'd go to Spain because I've taken lots of Spanish in the past, and it seems like a pretty nice country.
Cool. Okay, and last but not least, Molly.
Hi, I'm Molly. I'm a fifth-year computer engineering major. If I could travel anywhere in the world, I would probably pick Iceland because I know some people that have traveled the world and they said their favorite so far is Iceland.
Great. Those all sound like exciting places. Hopefully one day COVID will be handled and we can travel much more. I just want to remind you all that we use Slack to communicate. So if you haven't joined Slack yet, send me a message on MS Teams and I can get you hooked up. And once you join, it helps if you enable the notifications so then you know when we make posts. We have some upcoming events. Currently, we actually have the scavenger hunt going on. That's going on Slack. We just have a bunch of different like sustainability tasks that if you complete all of them, by the end of September, you could win a prize. You got 2 prizes for the first people who finish. We also have study tables each week. So tomorrow we'll have a study table from 10 to 12. You can come just to hang out, to study, ask questions if you have trouble with some of your homework. We also are going to have one on Friday from 11 to noon. And we're going to be having an event about voting for sustainability. It will cover how to research different topics in sustainability or different people that are running for offices or different issues that are on the ballots this year so that you can figure out what you need to vote for to help promote sustainability. That's going to be on October 22nd at 4:30 p.m. and it's going to be hosted by Terry O'Sullivan, who used to be a professor at the University in Political Science. I also wanted to remind you that tomorrow is National Voter Registration Day. We will be posting on social media and I think Slack to let you guys know how to get registered to vote in the surrounding areas. We have some projects going on right now. So right now we have the education team, which is run by Megan. They meet on Thursdays from 6 to 7, and they're currently working on putting some slides together for some outreach with K through 12. So if you're interested in joining, you can reach out to Megan or just show up in the education team meeting on Thursday. That's going to be on MS Teams. We also have Zips Precious Plastics, which is going to be an on-site, like on-campus recycling facility. We're in the process of making a shredder, compressor, injector, and extruder. We're also looking for a project leader for this, and we meet every Thursday at 5 o'clock on MS Teams. And then we also have bike power. Currently, they're working on putting together a list of parts that they need to buy to build our prototype. So hopefully we'll be getting to build that very soon. They meet on Tuesdays from 6 to 7, and Michaela is the project lead. So if you're interested, email Michaela or send her a chat message on MS Teams, and she can get you hooked up. And then we have today's speaker, Jörg Broning. He's the founder and owner of the Green Roof Service LLC, or Green Roof Technology. I'm pretty sure Jörg helped implement the green roof that we currently have on campus, and we're really excited to have him today. So Jörg, I'll pass this off to you.
All right. Yeah, hello everybody, and I like the icebreaker. First of all, it gave me a very good impression that, I mean, we got people from all fields, you know, this is really exciting. So, and it's also a challenge a little bit for me not to talk about certain things what are normal for me in my profession, and for somebody else may be difficult to understand. So if there's any concerns with the understanding besides the language barrier, then you are all welcome, and to raise your hand or to say something and interrupt me, it's no problem. I also like the idea with people where they would like to travel. I think this is really a key element in younger years, and I can only talk about experience. I didn't spend too much time at school. I mean, still long enough probably, but I spent more time with traveling. Whenever there was a cent left over, I invested that in some travels, whether it was with a motorcycle all across Europe, or as I said before, was actually it was a bus from Germany all the way to Ghana, to the center of Africa, and all these places. So travel was for me always very important, and it also gives you a completely perspective of basically at the end the place you are living, what I'm right now actually questioning too. So if this dilemma goes on, I have right now actually a couple plans actually going back to Germany and Europe, because my mom is very scared about the situation here. She knows that from the past, certain things, and she doesn't want me to be there. So it's difficult. But nevertheless, besides all the politics, I will start sharing a little movie. I thought I can do it, but I can do it, but it might take a little. Okay. I think I have to share the screen, right? It doesn't show my screen where I have the movie. This is kind of weird. So we practice. Kayla and I, we practice a long time until I get it, because I'm an old dude. It just takes longer, but obviously. Yeah.
So when you pull it up, try and click, there should be one that's labeled desktop or screen number 1. Try and click that.
Oh, screen number 1. Oh, okay. Let me see.
Perfect.
Can you see it? Okay.
Yes.
And you might be even able to. This is a movie I took this year, mainly this year, with a small drone in Germany, where I obviously started my career in Stuttgart, Germany, pretty much 40 years ago, a little bit longer ago. And there's a lot of projects I actually did, and they are obviously still existing. However, I was impressed on my own how many green roofs were added in the last 20 years since I'm in the US and trying to do the same thing here. So On one hand side, it motivated to do more here, but on the other hand side, I was also a little bit disappointed because in a 20-year time frame in Germany, the market and the green roofs increased really super proportionally comparing to the US, where it is still a very slow or very hesitant market. So we will see some of these pictures also during the presentation again, where I say a little bit more to that. A lot of these buildings are actually schools and universities. They have a very high percentage of green roofs and combinations, green roofs and solar. This is, by the way, one of my first projects. I did that in 1982. This is a hospital. That's an incinerator for the trash. That's another school. So I stopped the video there. It's just telling a little bit about how many people are living there, and Stuttgart has a very strong industry on one hand side. So Mercedes, Porsche, Audi, it's all from the Stuttgart area, and they have all the industry there. And Stuttgart is not making a big deal out of their greeneries everywhere. It's just normal for them. So it's very, it takes me always a lot of convincing for people in my hometown to write a little bit more in English that other people can see it also. But they rather do it instead of writing. This is obviously, but this is a little bit my thing too. So nevertheless, I'm going just seamless in the presentation where I think everybody can see that, right? It's, yeah, okay. So this was the starter for the movie, and a little bit to my person. So I am working in this business, in the green roof business, but also I started in the landscaping business, which is, actually landscaping is also responsible in Germany for the green roofing. So you have to have landscaping certifications or certified horticulture technician. What I am, and I started on the 1st of September 1980. With that, the education goes for landscaping 2.5 years, and for the horticulture technician, you need to have the trade landscaper, and then you have to work 3 years in a company, and then you are back 2 years on university. So it takes around 7 years to get this title. In the US, you can get this title in around 6 weeks online. So just saying the difference. So when somebody asks me whether I'm a landscape architect, I typically say yes in the US, because my qualification is so much higher than any landscape architect in the US. However, I cannot get a certification in the US as a landscape architect without running through the typical school system. So I don't have that. Long story short, I got pretty much 20 years ago, I got a call from an American company, a very small company, engineer firm, asking me for a green roof on a project in Chicago. And I thought this was super exciting. And I pretty much, since I like to travel anyway, so I booked maybe 3 weeks later just a flight to Chicago to meet this guy. He was from Philadelphia. It was kind of a crazy guy, but he was talking about the City Hall project in Chicago. And we went up there, and I was convinced that we can make this project and that we can get the contract. And so this was the City Hall in Chicago was my first project. And it was kind of a little bit the key project for green roof technology in the US. In between that, I have done projects all across Europe. And in the Dominican Republic, some of them, some others designed on other Caribbean islands, and then across the US. I mean, from east to west, I have everywhere projects. And with the green roof, I think I want to start with a point that right now, I want to change your view of things. And right now we are looking at architecture from a ground level. I call it almost a kind of a two-dimensional level. So it might everything look nice. And we are asking ourselves, why do we need green roofs when we have potentially a lot of green, in this case, more green color in the picture than other things. So we have to basically change our perspective, and we have to, wait a sec, okay, oops. And we have to basically fly like a bird, or we have to tip over the building to see what's on top of it. And if we fly like a bird, then we can see that we went from here to here. And this is, I think, in the Akron Cleveland area. So there's a big difference. I mean, the green is very obvious, but the green comes also with a lot of functions that are potentially here not existing, and I want to go to that. So since we have done, and this is the City Hall also, a few green roofs there, and in this case only a part, I think now we should go from here, from partially greening to entire greening. This is an area on Google from an industrial area in Stuttgart. It might be difficult to see, but all these buildings, with the exception of this parking lot has a lot of trees, and this building, but all of these buildings, they have actually green roofs. And what I also found really interesting, the main access to this industrial area in the Akron, and near Akron, it's a 4-lane or maybe even a bigger highway, and over here it's just a train with little stations along it, and the bigger highway is farther away. So with a train, this area is even more accessible and better accessible than with the car. All kind of interesting aspects and things I believe you will see when you go to foreign countries, how they solve certain problems. And one problem, obviously, and where green roofs and green infrastructure address, is the rain. So the rain is not the problem. The problem is actually the pavement. And you can see it here. This is an area just near downtown Baltimore with some housing, and this is a residential and commercial area in Germany, where every building, with the exception of this one, have green roofs and a lot of green around it. So the difference is very obvious. And even so they have all that stuff, they still have stormwater issues. They still have issues with other negative impacts from dense construction. This is an example. This is, I think, the Amazon Logistics Center in Baltimore. They are, by the way, hiring a couple thousand more people, and they are getting bigger. And a warehouse in Germany. And when you look at that, this is 2.5 million square feet or 57 acres. The roof has around 1 million square foot. And on this entire property, there's only 6 trees. So the runoff, the annual runoff of this property here is around 61 million, whatever, gallons. Approximately 100 Olympic-sized pools of water running off this property directly in the Chesapeake Bay, which is the 3rd largest estuary in the world and the largest in the US, a very important environment. On the other hand side, on this building, this was optimized for stormwater retention. They have pretty much the same roof size and size like this property here. They have around 1,700 plus trees around this entire property. And the annual rainfall is almost the same as in Baltimore, but the annual runoff is only 10,000 gallons, which is a semi-tank truck. So this is a big difference to see that. And so green infrastructure, green roofs can make a really big impact. And also, maybe at this point, I also want to say that cost-wise, this company with green infrastructure and retaining and keeping this water all on the property, they saved around 3 million euros in the construction phase, instead of having all this retention ponds and big piping to certain things and clarification and all that stuff. So it actually made this whole thing cheaper. So this is, again, this picture. So in the 48 states of the US, urban impervious cover adds up to 43,000 square miles. And this is basically right now almost the entire size of Ohio is impervious in the US. It's amazing when you try to get this data and these numbers together. And it's even more interesting, and this is in Europe, a very comparable, not as big, but it is comparable. You are adding every year 1,000 square kilometers or 250,000 acres of imperviousness. And this is, I think, a really a critical number already with flooding and pollution in the waters around. But it also has, in my opinion, a very high priority to be addressed. So typically 2/3 of the cover is pavement and 1/3 is building roofs, basically, on buildings. So I think even if it's only 1/3 on top of the buildings, I think it's an interesting aspect to focus that, because the building is already a structure, and typically the roofs of the buildings are not used for anything. So there is space, there's existing space and space that's open space. So it can be much easier used than, for example, a road. It's very difficult to cut a 4-lane road down to a 2-lane road and make 2 rows of trees to get some tree canopies. Would be great, but this is very difficult to get through. It's much easier to take an empty space on a building and put a green roof on it. And this is from the EPA, as the EPA was more functioning and not so much influenced from the coal politics. But they made this thing, this graph or this drawing when it comes to green infrastructure. So they have the tree canopies, they have rain barrel, even rain gardens where water is held better, obviously the green roofs, and then tree planter box. I think this is some of the ideas. I don't like the way they are executed. They could be done so much simpler. Working with nature, working with plants, it's sometimes much easier than people think. It seems for me like Americans are a little bit afraid of nature, and so this is why they always need a little wall or a barrier around nature, that it's not attacking humans. But I think it's the opposite way around. So nevertheless, and then they have the pervious concrete. That means you can change the water runoff also by using porous pavements where the water goes more or less straight through. And this would be something also for new roads, new walkways and all that stuff. Because when the water can drain into the ground, it is much easier to keep trees, for example, along the street alive, because they have a better supply of water. Then, well, I'm trying to maneuver a little bit to the green roofs, and I think this is a little bit my opinion, but I can certainly say that as green roofs got more and more popular, and the City Hall in Chicago was certainly a big deal for the US, and it was in all kind of media. It's still everywhere too. I think with the green roofs, people in the US also created the term green infrastructure, because they just not only wanted to say green roofs, and at the very beginning a lot of people didn't know whether a green roof is just a green painted roof or a copper roof that kind of turned into green, or whether it is a roof with thicker insulation, or whether it's a roof with solar panels. So the term green roof at the very beginning was a little bit misleading a lot of people, but then in the combination with green infrastructure or living infrastructure, I think it was getting better explained. So green roofs are very effective in reducing the environmental footprints of structures because they are utilizing existing and unused pervious space. So you can implement that relatively easy, and you have you are basically elevating an environment that had been in this place before at some time to the roof. So green infrastructure and green roofs, they help us, and I think I want to at the end point out a few things. Reduce the heat island effect. I think it's very clear for everybody of us when you are in the sun and you are standing on a parking lot of a mall, it's really hot. Even if you just step on this little green grass area aside from the parking lot, it's already cooler. It is cooler by temperature, but it also feels much cooler for people. And when you have even a tree there and you stand in the shade, that's where we always want to try to park our cars in summer, then it is also much cooler. So it's very simplistic that not only the shading effect reduces the heat and the heat absorption of the concrete and of the pavement, but it's also the cooling effect comes through the evaporation through the leaves, that they release water, and this creates this cooling effect. Then obviously it is clear that if you have more trees, more plants on top of buildings or within the streets or around buildings, you can create a biodiversity. A lot of people think when you have a lawn around the building, you have a lot of biodiversity. I think this is the worst case scenario, in my opinion. I think lawns should be minimized to very small areas in urban settings, and it should be more a diverse, even a meadow type style where you mow it maybe only twice a year, just to get some diversity, to reduce the chemicals. Lawn takes a lot of chemicals, and to reduce the work on it. On the lawn, you have to mow every 2 weeks. A meadow you mow, I mean, my meadow out here, I mow only once a year. So I'm always getting a ticket because they say it looks like mess, but it's just not regularly mowed. But I have honeybees and even snakes here in the middle of the city. I mean, I have everything here, and no rats. My neighbors have the rats. Then green infrastructure, and that's especially for green roofs, they protect the structure against environmental impact. The city of Miami, they require for green roofs, I think, at least 20 inch of growing media, because they assume that some of the growing media is blown away in a hurricane. I think they haven't got the idea entirely, because the roots will hold it together. But even that said, if they lose, let's say, 5 inch of growing media, the growing media, it's so fine and it's more like dust or maybe sandblasting something instead of the entire roof comes up. So the weight of a green roof, for example, in hurricane area, has a very high impact on the entire building and protects the building. But also that the waterproofing, the roofing material, under the green roof that keeps the roof watertight is basically protected against UV radiation, against temperature peaks, whether they go really down or really up during the day. So it's a very high protective layer of green roof. And then obviously green roofs reduce stormwater runoff and related costs, and these costs are they can be really high when you just think about certain floodings and certain infrastructure they want to increase or have to increase because there's too much stormwater, besides the pollution into these areas. So green roofs and living infrastructure hardly reduces the direct energy demand of these structures. I'm just saying that here, and I will probably mention that later on. A lot of people, they say that the green roofs reduce the energy use of buildings, And from my experience as a European, in Europe, there are very strict requirements how much insulation you need on top of your building. If you add to that a green roof, it doesn't matter anymore because it's already good insulated. But when I see here, and even this old building where I'm in there, there's zero insulation on the roof. Sure, then you have a benefit. But you always need to consider in summer, when the system is dry and the soil heats up, it's also storing the heat. So that means at night when it cools down, the soil is still almost like a radiator into the roof. So it keeps the building warmer at night, during the day a little bit colder. In winter, for example, if the system is completely wet and frozen, it keeps the cold much longer than if the roof would be a black roof and would heat up immediately. Even under freezing conditions with the sunlight, it would heat up very hot. So all this research and this, I think these claims are done by a lot of scientific and wannabe scientific people that green roofs save energy. They are, in my opinion, completely misleading because the truth is very low, and I wouldn't even mention it, but I address it at least a little bit to show it. So nobody has a question right now, right? Or does somebody has a question? No? Okay. Okay, so how does a green roof work? This is, by the way, Swarthmore College near Philadelphia. They have around 15 green roofs. So this is a soil profile of the natural soil out there. Everywhere it looks a little bit different. Certain layers in this profile, I think my mouse works here too, yeah. In different areas are different. So that means in some areas the rock, the base rock is much thicker, or the decomposed rock thicker or thinner, and the mineral layer is in some areas extremely thick and some is hardly existing. And then the area with the what people would call the topsoil, where you have organic parts in there, can be in some areas not even exist, in some areas can be relatively thick. And so, but this is in general, experts talk about a soil horizon. So there's different names for this horizons. I think it's not important now, but I think it is more important that a green roof, if it's done correctly, it has exactly the same horizon. It's trying to mimic these horizons, because this is what plants understand. Plants, when they seed, they need some organic. They grow much better with organic, but later on, they also want to grow down to groundwater level, or to areas where the groundwater rises up within fine capillarity channels within the soil. And the same thing, we basically, on a good system, we do also on a green roof. You have the roofing material, you have a coarse mineral layer here that retains or detains a lot of water. You have a filter layer, which I consider this as a filter layer because no organic can go through. You have a filter layer, and then you have a layer with organic material. Over here, this picture shows good. You have this foundation, this bedrock, and then you have a drainage, and then it basically comes to the growing media level and the soil, topsoil. So it's an engineered setup with high performance layer. Materials are different than here. We have often what we call lightweight aggregates. It's not because of the weight, but it's because of the porosity of this aggregate. So if an aggregate has a certain porosity, it mimics, it creates a higher surface area, and a higher surface area creates more fine roots for the plants. So that means they are spreading out further, and the porosity also exchanges, retains water and nutrients. So porosity is a key element. On a natural soil layer, there's not too much porosity, but the thickness makes it work. On a green roof, we want to have less thickness, but then we need better materials. The goal in all of these cases is to retain and detain stormwater. And since we have people from all the different directions, I want to briefly mention the difference between stormwater retention and stormwater detention. I'm not sure whether anybody is reading that right now, but to say it very simple, retention means you have a bucket and you fill the bucket with water, or you let the water go into the bucket. It cannot escape other than the bucket is full, and then it overflows to exactly the same amount as you pour it in. This is what some green roofs obviously do, and then they use this water for the plants. So they take this stored water out and use it for the growth in dry conditions. But since it's not slowly released, if a new storm would come in, it would further fill up and then eventually overflow to the same rate as the rain comes down. The stormwater detention works a little bit different. It's like a bucket with a lot of holes. So you can pour water in there, and then maybe on the lowest hole it starts to come out, but it doesn't come out in the rate you are pouring the water in. So it is time released water, so to speak. And this is kind of what a green roof does both. It retains, but it also detains. But the detention is getting now in the focus with newer systems where you have, I mentioned it below here, where you have smart drains. And these smart drains, what they do is, and there will be a little drawing coming up, they basically decide whether they want to release water or not, depending on the weather pattern. So for example, if you still have retained water from the bucket here on your roof, and there's a storm coming in within an hour, then the system says, okay, we release some of this water to the sewer system because there's no water right now. And so basically we dump some of the bucket or the entire bucket in the sewer system. This can handle it because there's no rain, but then we have enough room to add additional water when it's raining. And then we keep it, we can even over-saturate our system for between 12 and 24 hours and then slowly release it long after the rain. So that means the smart drains, this is the next generation, so to speak, of green roofs and blue roofs, what they call blue-green roofs because of the water holding. But you can also have just blue roofs where you pond the water and store the water on the roof for a certain time. I'm not going into that because I think it's a method only for buildings, for older buildings with low structural capacity, but it has not much benefits for the environments. So yesterday, and I mean in the past, it was yesterday, they already did some green roofs. There's the Torre of Giuinichi in Lucca, Tuscany, and some of the people wanted to go to Italy. I really, really recommend that. So this is around 300 or 400 years old, this building, and they have planted oak trees up there that are growing further. In this city, Lucca, it was 300 years a kind of a prestige thing to build your building as high as possible. So the higher your building was, the more prestige, the more you were honored within the city. And this guy, he had only a small property, so he had obviously it relatively easy to build it higher, but on top of that, his idea was to plant some trees that his tower continues to grow. Good idea, works still today, 300 years. Rockefeller Center in New York, it's now, I think, around 100 years, the green roof. They had to do some repair, but there's also some still original setup. And when you look, I always look at the soil profile. When I look at the soil profile from these old drawings, I can see different soil horizons, and also with the no humus added, that means there's no organic. So they had exactly the ideas, or what I said before, the soil horizons in mind. They have understood the soil horizons, and they were trying to mimic the soil horizons. For me, this was very important, as I discovered that, because I understood with the current green roof industry in the US that a lot of people don't understand that, and that's why a lot of green roofs are not necessarily performing very well, because they don't get the basics. But it was done before here, and there's even a patent on this kind of setup, so it could have been done everywhere, but obviously it was too expensive. So today we have basically different types of systems, and these depths of systems with the depth of soil, the weight, and all that stuff, this is just an example. You can make this system even thicker, and you can make this system also, like this system, even thinner. The main difference today is that mainly people build green roofs with this drainage boards. These are plastic boards. I'm not sure whether somebody can see me here, but this is something how it looks like. I can show it a little bit later again. This is done for weight reasons and for drainage reasons. They have good drainage and they have a very low weight. But from an environmental perspective, even if a product like that is 100% recycled plastic, I think it's not necessary, because there is a limited lifespan even to this product comparing to a mineral lightweight aggregate. If I think about a lightweight aggregate like pumice, then I have to say this material is already around 50,000 years old, and then I can guarantee my client it will make another 500. I can do that. With this plastic, they have issues over time. I would say in a 100-year frame, where they kind of break and where the roots have, take it apart. And it's also something the plants don't necessarily understand a piece of plastic like that. They are growing differently in this, and it takes a longer time. Nevertheless, this is where people make money within green roofs. It is as it is. Many things we cannot change. I have to use it sometimes too for drainage reasons and all that stuff. I think this is good, but I'm always aware of that this might not be the last. You see the products here actually also. I could have shown it just here. But anyway, this is you start on top of the waterproofing with a protection fabric. Then you have a drainage board or the granular drainage from here. You have a filter layer, the growing media. This is an engineered soil also with porous aggregates. And then you have the plants. Could be any plants. In this case, it's sedum plants. This is tomorrow. This is a system I'm working on over the last 2 years probably, and now I'm getting some of the really small, enthusiastic and engaged green roof companies within the US, but also outside the US, in Germany, in Italy. I have the Dominican Republic, and then also in Saudi Arabia, to create a different system, a system that's on one hand side certainly focusing the health of the plants, but also giving opportunities for water management, stormwater management, and in desert states, for example, irrigation management. The system is, I call it a platform-based monolithic modularity. The key of this system is kind of a plastic material, unfortunately, a plastic material, but this is an open grid with approximately 90% open space. And installing this directly on the roofing, once the roofing is installed, actually other companies or other workers in the construction, they can actually drive and walk and do everything what they want to do on top of it without damaging the waterproofing. This is right now, when it comes to leaks on roofs, this is right now the #1, and maybe the 50% of the leaks on the roof are done during the construction of the roof. Even roofers, when they have nails or screws laying around, they don't even move it away. They sometimes step into it, and then you have already a leak. So the idea was to create a platform where everything is away from the waterproofing and people cannot damage this roof anymore. This is for the construction at a very early stage. So in this case, the green roof will protect the waterproofing already during the construction. You can also use it as staging area and all that stuff. And then the next step is that you can fill this up if you want to, or if it's necessary for a certain project, with the granular media that retains a lot of water and creates the environment plants know about. Or you can leave it open and you can have a floater keeping the water to a certain water level, where the smart drain is at the end telling the system you have to release or not. You don't even need to make a green roof on top of it. You can also have just pavers, and then you have still water retention under the pavers. Another key element is that all things like solar panels, railings, planters or safety equipment, even air systems, you can install on this system. You have no penetration through the roofing anymore, so everything is safe and disconnected from the building itself. This is the idea, and you can make any depth of system. So it's a very flexible system. The idea was to have only a few materials. So this can be done with 5 different components, and then you can make any type of green roof out of it. This is the idea, and this is what I think will be the next generation of green roofs in the US. I hope so. And by the way, I made it also as an open source system. So all the companies I want to have engaged within the system, they can use their own components. This running in the background, it's a typical stormwater runoff of a conventional roof. That means on a non-green roof. You have the rain coming in, and it's raining and raining and raining. It's getting stronger, and then you got basically the rain stopping, and you got also the runoff. The water basically just as it comes down, maybe with a 5-minute delay, depending on the intensity of the rain and of the type of the roof, the slope of the roof, there will be some sort of detention, but it's not very much. When you do the same thing on a green roof, this is a very thin layered green roof system. So first of all, you have a certain retention that stays within the system, but then when the rain stops, the detention, I mean the runoff, is really delayed, and there is a delay in runoff. This is why green roofs are really popular right now. This hour delay, 2 hours or 3 hours delay of the runoff is a big relief for city sewer systems and drain systems within the city. So this is where they are looking for. It can be done with different components. It can be more delayed or less delayed. I'm hesitant sometimes with sponging elements like a mineral wool or something like that, what people use as a growing base for the green roofs. These systems retain, they hold too much water, more water than the plants can deal with. Plants want to have a certain air to water ratio. And then we have the, is that working? Oh yeah. Then we have kind of a blue-green roof, or I call it also here blue paver roof, because you can also just have pavers on it. So this system is basically releasing some water before the rain. It is connected with an app to the roof drain, with a weather app, and it tells the roof drain, okay, we are expecting a rain in an hour. Give us as much capacity to hold the water, so drain it, and then it will drain. Then we have the rain coming in, and then the system will decide at a later point whether this is too much water retained or whether there's another storm coming, and accordingly it will either open the drain or will just partially open long when the rain is gone, and basically when the sewer systems are able to take additional water. So this is kind of the smart controls for green roofs. It's kind of this is the next step, and the system, the monolithic platform system, would support something like that very easily and very simplistic. This is the future, so to speak, but we are here right now, which is already a big belief. So what are the considerations for green roofs and for green roof? I think it's very important. I got a lot of call from people, whether it's in the neighborhood or from others. They say we have this row house. It's built in 1920, and it has a flat, slightly sloped roof, and we want to have a green roof on top of it. In most cases, I have to say it's not working, because the structural capacity, and I think this is the first point, is just not given on these buildings, which is really sad, because in America, more residential homes, especially in city areas, have flat roofs than in Germany. In Germany, a lot of residential houses, also within the city, they have sloped terracotta tile roofs, and it's very difficult to make a green roof there. It's possible, but I think it's cost wise makes not really sense. So there would be a great potential, and I have developed here for Baltimore, sometimes on this planning commissions, a couple ideas how you could connect 10 row houses and cover them with one roof that's structurally sitting on the walls of the buildings, and then build a green roof on top of it. The space between the new roof and the old roof could be good used for air conditioners and stuff. But it is, everybody wants to have their little own 2x4, 4x8 box. They don't want to touch anything from the neighbor. I think a lot of the issues here in the country is with liability and lawsuits and stuff like that. So it's a very long way. Maybe we are getting to that in this direction later, when a 1920 building is just too old and doesn't meet any insulation or technical requirements anymore, because we have to face it as it is. These buildings are hardly insulated in the first place, starting with the windows, often old windows. Nevertheless, so if you think about a green roof, if you think it can be done everywhere, the structural integrity of the building is important to know. This is always my first question when I get a call in regards to green roof. The second thing is that you need to make sure that the roofing material, the waterproofing, is not only leak-free, but it is also done with a type of waterproofing that it's compatible with the green roof, that it works with the green roof, where the plants cannot drill little holes in the waterproofing. And then sometimes it's nice when you can hang up your light on the inside of the building on a piece of wood, but it's not necessarily my thing. And then I also think with green roofs, you have to make considerations that the plants are always healthy and vital, because without the plants, a green roof is not a green roof. And that means also that the maintenance requirement for your roof will be a little bit higher than a roof without a green roof, obviously. I mean, every roof should experience at least an annual maintenance. On just a flat roof, on a normal roof, it can be done relatively quickly. On a green roof, you are spending some more time there. And I think these are all part of the considerations. And then I always get the question, what are the costs for a green roof? And the costs for a green roof, I always try to answer it this way. So a green roof is potentially $15 a square foot. If it's a deeper system, it is maybe $25 or $35. It could be $45. If you have amenity space, it could be $100 per square foot. It all depends what my picture is of the green roof and what I want to have. But then you can also, as an alternative, you can also look for riding a jet ski in the backyard. This is priceless. and pumping out the basement, actually. So I'm getting closer to the end, and I'm not sure whether everybody is exhausted, but I have certainly, I think, some time for questions. So what are the incentives for green roofs? And I call it incentives and benefits at the same time. By the way, this is just finished. This is in Düsseldorf, a shopping mall, and they planted, I think, around 150 or 180,000 trees in planters all around the building and on top of the building. And this has also a smart irrigation system with the water, so it can control the system. But what's even more important, there are little rails behind this where they can run an automatic hedge trimmer with a vacuum that keeps the these trees and hedges always in the same shape. So it goes almost fully automized, the system. Very interesting project. I wasn't able to go there, but maybe this is on my list for the next vacation. This picture, this is in Akron, obviously, at the University of Akron. I'm not sure whether it looks like that today. I took this picture, I would say 4 years ago. So what are the incentives? Does it show? Yeah, so green roofs, green infrastructure, putting that together improves stormwater management. This is the major issue within the United States, it's stormwater. A lot of cities and a lot of places don't admit to that, but that's it. That's very, and this is also what on your water bill makes the water bill in many places super expensive. Then I just said it, it reduces the stormwater fees. So with green roofs or with a good stormwater management on your property, and green roofs would be the best and easiest probably to do, you can reduce a lot of your stormwater fees, and these fees are going super proportionally up in the next year. So basically a green roof will pay at the end for itself. Reduces urban heat island effect. I mentioned that at the very beginning. Green, evaporation, cooling, shading, everything is there. Improves air quality, so plants breathe, so they breathe in and breathe out. So basically they capture some of the carbon and breathe out oxygen. They also do it the opposite way around, depending on the daytime. But overall, if the plant is adding growth to itself, so if it's getting bigger, it will store a lot of the carbon within the plants. So it certainly improves the air quality. It also, all the leaves are like little filters in an urban setting where you have a high pollution. Improves efficiency of mechanical equipment. So having an air conditioner on a roof and getting the air intake from the roof. On a green roof, it's much cooler than on a non-green roof where the surface temperature of the roof is much higher. Reduces greenhouse gas emissions. Yeah, well, this goes a little bit in relation with the this goes in relation with reducing the urban heat island effect. So if you reduce the urban heat island effect, you have less energy needs for air conditioning and even heating and cooling. And so I call it the indirect energy. Increases water quality. So basically the water that's still controlled or reduced running off the roof has already run through one filter, through a soil filter, and it will increase this quality. Extends the roof life. I think this is a very big thing if the roof is done right in the first place. And this is where the industry, my industry here, the green roof industry, is right now still trying to emerge to get good craftsmanship for a roof. Then it can extend the roof life. I have shown a project that's 40 years old. They are not intending to replace the roofing in the next 20 or 30 years. So I would say it can extend at least by 2 times, more likely 3 times. big saving, big payback. Then provides urban amenity. Yeah, you can sit out in the green directly on your building. You don't need to leave it anymore. Increases the value of the structure, and this goes a little bit with the amenity. A lot of buildings in New York are getting really a high rent or sold at a really high price if there's a green roof, if there's green amenity space on the roof or around the floor in the building when that's involved. So it certainly increases the value of the building. And then I say potential reduction in cooling costs. I think not directly, more like indirectly by the cooler air. And then you can green roof. It's typically eligible for PACE financing or for grants. And for sure, if you have a green roof, you are the hero. It's a prestige thing. I think this is sometimes the most important part in the US. On many projects I work, you can put this argument on top because they just want to look good. And then they didn't care what it costs. But I don't care, both works for the environment and then it's good. So this was my presentation so far. This is a project also in Germany, and I think this has an interesting aspect. So the road surface here, this is paved, it's impervious, and then they covered it with another 5-story parking garage impervious, and to eliminate all the imperviousness, they put a green roof on it, and the solar panels, both buildings produce energy for, I think, 380 residential homes. All right. Okay, dokie.
Thank you, York. That was great. I have a few questions. I don't know if anyone else does. I can go first. So I was wondering how the green roofs handle like large amounts of rainfall. Like I know there's a lot of hurricanes going on with climate change. They're expecting more intense weather, I guess, in certain areas. So I wasn't sure like what happens, especially if it's a retaining green roof. Does it just flood? Like are there gutters around to deal with that flooding water?
That's a very good question. And one reason why I worked on this development for the next generation was actually the climate change. That means this system is able to take up a huge amount of water, and you can adjust it. You can make it even with the open space thicker, that you can get a full hurricane just sitting on the roof, you know, for as long as you want, until all the floods on the ground are gone, and then you can release it. Then you pull the plug and it goes. So with this system, you can do that, and you can capture a huge amount in a very short time. This engineered soil is made to run the water basically vertically first, like almost in nature. I have seen green roofs where this is not considered, where they just put some sort of dirt up there. They call it even dirt. So I think it was dirt, was not a soil. And then this clogs up, and then the water runs on the surface of the soil and takes up also some material of the soil, and then you have almost what you have on the ground. You don't want to do that on a green roof, so you do it differently. So you can adjust a green roof to, actually the green roof industry has to adjust to the future environmental issues. And with this system I mentioned, you can go also vice versa. For example, in California, if you would have had this system on a roof in California, you can actually flood the roof with potable water before a fire. Then you have a 3-inch water sitting on top of your roof. So it's very unlikely that the fire goes from top down. Then it can only come from the side. You know, I'm just saying that. I mean, there's so many, and this is also why I have it developed. For example, in the desert states. I mean, when they have basically 5 inches of rain a year, you know, you have to give them a chance of irrigation. And with that, you can subsurface irrigate. And I have done roofs like that 40 years ago, and then they have only a floater for the water level. So if the water level drops, this floater turns on like in your toilet and fills it up to a certain point. So at the end, the plants are regulating the irrigation water. If they take out a lot of water, it turns on quicker. If they don't need so much water, it doesn't turn on so quickly, but it's away from the environment. It's not a sprinkler. You know, a sprinkler, if you have a sprinkler system in the desert states or even in Saudi Arabia, and they have that because water is really cheap, what they have, it's subsidized. But a sprinkler brings only 20% of the water to the plant. The rest goes directly in the air. This is amazing, you know, I mean, this is unbelievable how wasteful. With a subsurface system, you don't waste any drop. You can even use gray water for that. So basically you can even use processed toilet water and pump it up there. Yeah, seriously, I mean, it's all good. It's nutrients, you know, this is what happens in nature. But long story short, so I think it needs to be more considered, and also with the idea that a green roof, when I claim it lasts at least double as a regular roof, you know, or extends the lifespan, then I have to design a green roof that it meets the requirements or the weather issues we have in 40 years. And they will be very different. I mean, in the next 40 years, you will see a lot of, I might not see it, I might already maybe too old, but you guys, you will see it, and it will happen. There's no question. So, but anyway, long story short, yes, it's important to adjust that. And this is why I think I'm using my experience somehow to bring these things to a next level.
Thank you. Does anyone else have questions?
I have one real quick. So you gave a lot of examples of like trees on roofs and everything. How do trees establish a strong enough root system in such shallow soil?
Also, a very good question. So when you say shallow soil, then you look at this extensive green roofs that might be 4 or 10 inch or something like that deep. Sure, if you have a tree, you need a deeper rooting system, and you need deeper soil. And there's materials out there, and that's what I said with porous material. If you use a regular river rock in this size, you can measure the surface area of this rock very easily. If you use the same size of rock as a lava rock that has some porosity, the surface area of this rock would be already 5 times bigger than of the river rock because of the porosity. If you would use a pumice instead, the surface area would be probably already the size of the block I'm living in, so 500 yards by 500 yards. It's amazing how the surface area increases. If you use materials like, also natural materials, by the way, zeolite, their surface area would be maybe 3 or 4 blocks, even if it looks like only like that. And with this increase of surface area, the plants and the trees are able to grow much more fine roots. Basically the same amount of fine roots they would grow in a deeper soil. So we are kind of tricking the plants a little bit. And I think you are absolutely right. I think it's very important. There's always a balance of what you see on top is also below, but you have to provide this. But also with that said, some of this porous material, I actually have here, I'm not sure, I don't know if you can see, you cannot eat that, and I cannot open it actually. But anyway, this is a recycled glass. This is a highly porous material that's made out of recycled glass. It's very simple. It's called a foam glass. It's very lightweight. I mean, this is had hardly any weight. And with this material, I can create very deep systems for trees on a roof that have hardly any weight. At the end, the weight of the tree will be at the end heavier than the entire system I use as a setup. So I have to consider that for sure the weight of a tree too. I hope this was some sort of an answer, right? everybody's doing this. Well, I do this too.
And then
Yeah.
go
Sorry.
ahead, Kayla. No, you can go ahead. You're good.
No, you go, Nora. Go.
Thank you. I also had a question. So I know that in the US, you brought up like a lot of wastewater treatment plants are going through expansion projects to be able to handle, a higher capacity of wastewater, and that's because of, the increased storm events and wet weather situations we have. And I know there are also projects where they are trying to split combined water lines so that the stormwater runs off directly to like the lake or the river. Obviously, I think green roofs would be really beneficial because the water that comes out is technically clean, right? So can't that, in theory, be directly released to the lakes or the rivers, or would that have to be treated as well?
Yeah, this is a nice question. So basically, what they call it in cities right now, it's a combined stormwater sewer system. So basically, the stormwater and the sewer goes in one, and then it goes in a treatment facility. If you have a heavy rain and the amount of water in the treatment facility is getting too big, they just open the gates because they don't want to be flooded out. They don't care whether the city is flooded out or whether all the pollution goes in the rivers and in the base, but they don't want to be flooded out, and they cannot be flooded out because this would be even more expensive, So they just open the gates, and often it's diluted by the rainwater, so they meet certain quality requirements because it's just diluted. It's a nightmare, and this is happening, I would say, every week, once in some, or basically daily, maybe wherever it rains in the US. It happens in Germany still today too. The problem is that with the stormwater, a lot of pollutions come in. I wouldn't separate that. Even from a green roof, a lot of people use green roof as gray water for toilet flushing and all that stuff within the house. This is relatively clean. It has, because of the plants and the organic parts, a little yellowish view. And a lot of people don't like that when you flush your toilet and it's yellow. It looks a little bit weird. Then you flush it again, it's still yellow. But anyway, so this is, but the water quality is relatively good. There are materials where you can get a better clarification in the growing media, where you could do that. This water is good, but if you get stormwater from a roof, from a green roof that's clear, into stormwater in a stormwater pipe from the road, and this would be in this case the same pipe because both would be stormwater, I think the water would be still high polluted because you get a lot of rubber, oil, and whatever, that animals and trash coming through the stormwater. So I think it would be still need to be treated. A two-pipe system makes potentially sense in entirely new developments, and then you can really regulate it. In existing developments where the infrastructure is in the ground, putting a second pipe in the ground, it would increase the costs of the infrastructures dramatically. And I know it from Germany, where storm pipes and wastewater pipes, they are combined. This is why they want to have the green roofs. But they are made on a 100-year design. So when they design it today in a new area, it needs to last the next 100 years. They don't want to repair it in 20 years or in 50 years. And this is most cities, older cities in Stuttgart, their sewer system is sometimes older than already 100 years, and it's still working. But this is how it pays back, So they are rather saying, okay, we have to cut off the input. We have to have more trees, we have to more bioretention within the trees, in the roads, more green roofs, then we can make the city denser. So the water is good, relatively good when it comes from a green roof. This was kind of the question, but when it's getting mixed with runoff from other areas that are not green, then it's as bad.
Great. Okay. Thank you so much for answering.
You're welcome.
I have one more question, York. I was wondering if biofilms or like fouling is a concern for that newer roof that you were showing, where there's like a layer of plastic that kind of can store that water. I wasn't sure if you get erosion or biofilms in there that you need to worry about.
Yeah, there's a lot of research done when you have the ponding water. And if you have the ponding water with not within a granular material, just that floating, you should almost let it go once a week. And the smart drains, they do that. In many cases, they do it even on a shorter cycle, so 48 hours or something like that. But at the end, it's all about how you create the logarithm and the program for a specific location, where you can say, okay, well, we can keep it a little bit longer there. If it's under the entire planted area, I would have no problem to keep it there for a year. You know, this wouldn't be a big deal. But if you have it also then under a paved area and all that stuff, you can get really problems. This is why I think it is better to fill it up with a granular media. You know, you can hold a little bit less water, but it's all this lightweight aggregates, these porous aggregates, are also used in wastewater facilities for filtration. So this is the better filter, you know, and then you would have no problem, in my opinion. I mean, I have seen a lot of green roofs that had by nature standing water because the roof drain was on a higher point. And the plants, when they plant these little sedum plants, the succulent type of plants, they will die because they cannot deal with this water. But then some other plants come, but everything is still kind of walking. You know, nature finds a way back, even if there's some standing water.
Thank you.
You're welcome.
Does anyone else have questions?
It's almost like everybody's oversaturated.
Well, thank you, York, so much. It was great having you. We learned so much about green roofs today. Yeah, thank you very much.
Well, it was my pleasure. And I mean, if there's more questions coming up and you want to collect them or something like that and send it, then I'm more than happy to answer that.
Absolutely. Thank you.
Yeah, thank you so much, guys. Yeah, thanks. Have a good rest of your day.
Thank you. You too.
Thanks. Yeah, thanks.
Bye.
Bye. Bye-bye.
Thank you.
Thank you.